Neural networks are the backbone of AI, powering everything from self-driving cars to voice assistants. But what are they and how do they work? Let's dive in. Neural networks are inspired by the human brain. They consist of layers of nodes or neurons that process data. Each connection between nodes has a weight which adjusts as the network learns. This learning process is what makes neural networks so powerful. Gap 2S. Imagine a newborn baby. At first it knows nothing of the world, but as it experiences life, its brain forms connections and learns. Neural networks work similarly. They start with random weights, and through exposure to data, they adjust and learn. This evolution is what makes them incredibly effective at tasks like recognizing images, understanding speech, and even playing complex games. Just like a baby learns to recognize its mother's face, a neural network can learn to identify patterns in vast amounts of data. It's this ability to learn and adapt that sets neural networks apart and makes them a cornerstone of modern AI. A neural network is like a digital brain. Inspired by human neurons, it's a system of interconnected nodes that process data to learn patterns. Think of it as a team of workers passing notes, each tweaking the message to solve a puzzle. In a neural network, the input layer receives raw data. For example, in image recognition, the input layer might receive pixel values. The hidden layers then process this data, identifying patterns and features. Finally, the output layer provides the result, such as identifying the object in the image. Here's the basic structure. An input layer takes raw data like pixels of a cat photo. Hidden layers, the magic middle, analyze features like edges or textures. The output layer decides, yup, that's a cat! Gap 3S. Now let's dive deeper into the core components, neurons and synapses. Neurons or nodes are the basic units of a neural network. Each neuron receives inputs, processes them, and then passes the information forward. Think of neurons as tiny decision makers in our digital brain. Synapses are the connections between these neurons. They carry the signals and determine the strength of the connection, known as the weight. Just like in our brain, stronger synapses mean more influence on the next neuron's decision. The interplay between neurons and synapses allows the network to learn and adapt, mimicking the way our own brain processes information. This underlying structure is what makes neural networks so powerful and versatile. Each node applies a weight to its input, adjusts it with a bias, and passes it through an activation function like ReLU to decide what's important. This process repeats, refining predictions through training. Training a neural network involves feeding it large amounts of data and adjusting the weights of the connections between nodes. This process is repeated many times, allowing the network to learn from its mistakes and improve its accuracy. The goal is to minimize the error or loss between the network's predictions and the actual results. Training uses massive data sets and a loss function to measure errors. Algorithms like backpropagation tweak weights to minimize mistakes, making the network smarter over time, kind of like studying for a test. Neural networks aren't just theoretical concepts, they have real-world applications that impact our daily lives. From powering voice assistants like Siri and Alexa to enabling self-driving cars, these digital brains are everywhere. They analyze medical images to assist doctors in diagnosing diseases and even help in predicting stock market trends. Understanding their practical uses can give us a glimpse into the future of AI and how it will continue to revolutionize various industries. Now let's explore the main types of neural networks, each designed for specific tasks. There are 4 you need to know about, and they're game changers. Convolutional neural networks are designed to process grid-like data, such as images. They use convolutional layers to scan the input data and identify important features. This makes them highly effective for tasks like image recognition and object detection. CNNs are widely used in applications like facial recognition and medical imaging. First, feed-forward neural networks, or FNNs. Data flows one way, from input to output. They're great for simple tasks like predicting house prices or classifying emails as spam. Picture a straightforward assembly line. Recurrent neural networks are designed to handle sequential data, such as time series or text. They have connections that loop back on themselves, allowing them to remember previous inputs. This makes them ideal for tasks like language modeling and speech recognition. RNNs are used in applications like chatbots and machine translation. Next, convolutional neural networks, or CNNs. These excel at image processing. They use filters to detect features like edges or shapes, making them perfect for facial recognition or medical imaging. Think of CNNs as a detective scanning a photo for clues. Now, let's talk about transformers. Transformers are a type of neural network that use self-attention mechanisms to process data. They are highly effective for tasks that involve understanding context, such as natural language processing. Transformers are used in applications like language translation and text generation. They have revolutionized the field of AI, enabling the development of powerful models like GPT-3. Third, recurrent neural networks, or RNNs. They handle sequences like sentences or stock prices by looping data back to remember context. They're used in chatbots and speech recognition. Imagine RNNs as a storyteller recalling earlier plot points. Neural networks are transforming many industries from healthcare to finance. They are used to develop advanced technologies like self-driving cars and personalized recommendations. As neural networks continue to evolve, they will unlock new possibilities and drive innovation in countless fields. The future of AI is incredibly exciting, and neural networks are at the heart of it. Finally, transformers. These power modern AI like ChatGPT. They use attention mechanisms to focus on key data, excelling in language tasks and even image generation. Transformers are like a super smart librarian finding exactly what you need. Neural networks are revolutionizing tech, and their types make them versatile for countless uses. From CNNs to transformers, they're shaping our future. Want more AI insights? Hit like, subscribe, and comment your favorite neural network type. See you next time.